All right, we're recording. Hey everyone, this is Cameron Motevasselani. I am, well, let's go to the slide. Who am I? Welcome to the plugins talk. Who am I? I'm Cameron Motevasselani. I'm a software engineer over here at Armory. I've been contributing to Spinnaker for the last almost 2 years now. So I'm a Spinnaker contributor and I co-lead the platform SIG on the Spinnaker side of things. My contact information is here. Reach me at Cameron at armory.io. I'm also on GitHub at link.08, but I'm also pretty active and available on Spinnaker Slack. All right, let's get into our agenda for today. We've got a decent amount to cover. We want to cover some plugin concepts. Let's talk about a few different ways of extending Spinnaker with the plugin framework. We'll talk about some backend development, a few different styles that we can attempt there, and then some front-end development. Then we'll finish it off with build and deploy. Should be fun. Then we've got a workshop section of this, which is going to be the main event. So either you have a Spinnaker set up now, or we'll help you set up Spinnaker. That will be an interesting endeavor there. I hope it goes nice and smooth. We'll be adding a plugin to that Spinnaker installation, and you'll be able to clone the plugin code down, build it, run it locally. So we'll be targeting Orca for a custom stage today. So we'll be able to debug into your plugin code and then connect to your running Spinnaker installation via telepresence. And then we're going to be making a request to another service. In this case, we're going to be talking to Echo and getting a list of PubSub subscriptions and then returning that back to the pipeline application context. Pipeline context, sorry. This might be a lot of words that don't make much sense, but we'll start diving into all of this. By the way, I'm in chat, so if you guys have any questions, please post them to chat. I'm here and ready to answer your questions. So let's talk about some plugin concepts. Okay, cool. So plugin concepts. We've got a few different concepts up here, and we will be digging into each one of them a little bit. So what's PF4J? We're talking about plugins. This is a plugin workshop. About a year ago, we added a plugin framework to Spinnaker, and we're using this plugin framework called PF4J. Let's go check out what it is. This is PF4J. It is the plugin framework for Java. It's pretty aptly named. It does what it says. So here is it's an open source project. We use a lot of PF4J update within Spinnaker. We're slowly replacing bits and pieces of it that are more Spinnaker specific. So we're actively involved in updating the framework, either on our side or asking questions on the PF4J side, trying to make improvements. There's some different components here in PF4J that we use on the Spinnaker side as well. So we create plugins. There is a plugin manager that manages all the different plugins. We're not going to get too deep into these types of details. There's a plugin loader that loads the plugins into your application context. We will be talking a little bit more about extension points. I believe that's coming up next. And then extensions as well. So let's go back. So let's talk about extension points. What is an extension point? So Spinnaker's written in Java, so I believe most of us know Java. And we are, or if you're not familiar with Java, there's this idea of interfaces, right? So you might have an interface for something. Extension points are interfaces on steroids, I guess, let's say. So essentially, what an interface is a set of like function names that you can implement and then get some functionality right out of the box. You might not have to worry about setting up your configuration because the interface deals with that. That's a kind of a weird example. What an extension point is a piece in the code where if you implement the extension point, then your plugin will just work with the rest of Spinnaker. So what we're going to be taking a look at today is going to be our PF4J stage plugin. The stage plugin, we're going to be looking at Orca today. So if we actually take a look at Orca, and sorry, we will be jumping around a few different places today. So let's check out the API package. In all the services API packages, that's where our extension points are. So if we check out our source, main, Java, blah, 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 and if we go, these are essentially the different extension points we've got in here. So we're concerned about making a custom stage today. So if we check out our stage definition builder, we can see that it extends. Let's open it up. We can see that it extends a Spinnaker extension point. Okay, again, we've made some improvements or built some wrappers on top of PF4J. So while there's a PF4J extension point, we have our Spinnaker extension point, which is just more custom to Spinnaker itself. So what this means is you can implement Stage Definition Builder as a plugin, and it will get wired up to the rest of Spinnaker and will act as a native stage. So that's pretty cool. That's the whole reason we're writing plugins, is we want to extend Spinnaker to do things that we want to do that it doesn't currently do. So this idea of extension points is pretty powerful because it's like a golden path for hopping on to what Spinnaker already does. Spinnaker manages stages and tasks, and this is a way of looking into that lifecycle. Cool. So an extension is going to be the plugin side of that. So there's this Spinnaker extension point in Stage Definition Builder. And how do we hook into that? Well, if we create a similar, instead of an extension point, we will utilize the extension point with an extension. That's what we're doing here in this class. We've got a plugin wrapper that essentially is, the random wait stage is what inherits from it. And the random wait stage is the stage. It overrides the task graph, which, as we saw here, Stage Definition Builder. Task graph is the method to override if you want to hook in with the stage lifecycle. Cool. Any questions so far? Just a little bit about telepresence. Yeah, you do need OSX views. We won't be going too deep into telepresence today, but I can provide a doc that after this that shares a little bit more info on it. Totally. So if you want to utilize an extension point, just extend it in your plugin code. And we'll be going over all of this in more detail. Great. So you have an extension there. How does it get wired in and looked up? Well, we've got this other concept called a plugin. And that's essentially what is the entry point for all of the code that you're writing. So you have to have this plugin class, and you have to inherit from the plugin class, and you can have your own start and stop methods. For myself, I usually use these methods just to log out to show that, hey, this is working, it is getting loaded in. I can be confident in that. But you might want to do some initialization here or whatever. So this is the class that instantiates your plugin, gets it loaded. There's not too much going on here, but in another example later on, we'll be seeing a little bit more about the motivation behind having a plugin class. And then now we're going to talk about a few different personas here. There's a plugin developer, a Spinnaker operator, and a Spinnaker user. So I assuming everyone who is watching this video is either is one of these three. Hopefully you are maybe a Spinnaker operator or a Spinnaker user, and you're coming here to level up into a plugin developer. So a plugin developer is someone who wants to write a plugin and add some functionality and share that with the world. There's a few different ways of extending Spinnaker that maybe we'll touch on later that are more lightweight, but then it's harder to share. I guess let's talk about it now. You can have a pre-configured job stage that you configure in your Spinnaker configs, and you can, it's essentially like a run job. You can give it a container to run, inputs, outputs, and then it'll run your container for you, and great. So why would you want to do a plugin? Well, if you want to update that or share your pre-configured run job stage out with the rest of the world, you're going to have a hard time with that, let's say. There's going to be a lot of manual configuration, and you're not going to be hooked in with the plugin lifecycle, which has many benefits as we're learning over time. And we keep adding to the benefits, let's say, like compatibility and stuff like that. Compatibility tests, etc. Spinnaker operators, they're the ones who are operating Spinnaker, managing the configurations and making sure it runs smoothly. They may or may not be the targets for the plugins that are being created. They'll be adding the plugins to Spinnaker installation, but if it's a custom stage, for instance, the Spinnaker user is going to be the one using it, right? So there's this separation of Spinnaker operator, which is more your typical like DevOps type role, and then you have a Spinnaker user, which is more your application developer, who might be creating pipelines and or just using pipelines that the Spinnaker operator and the DevOps team have like essentially blessed, right? But that's kind of the power with Spinnaker, is you can compose your own pipelines and be in control of your destiny. Cool. So Spinnaker users might say, hey, I want to do this thing. I found this plugin, Spinnaker operator, do you mind adding it to our Spinnaker installation for use? Cool. Let's talk about extending Spinnaker a little bit. So there's a few different types of plugins, and a little bit of background here. We've gone from an MVP plugin framework to the V1 plugin framework, and now we're on V2 as of the 123 release, which I believe was Monday. So it's a pretty recent release, and we are continuing to improve on the release. I see there's a question, can we do custom pipelines using plugins? That's a good question. My thought with that is you would have stages that you would create. They might be custom stages, they might not be, they might be native stages. Rather than having a custom pipeline, I would probably create a pipeline via code. So have like, what was it? Managed template pipelines, or Armory has a Dingy service that you could use, and it's a way of managing pipelines and templates that you can share and save around, share across your organization. But no, at this time you wouldn't create a whole pipeline per se with a plugin. Yeah, I mean maybe you could. I haven't really thought too much about that. Pipeline configurations are saved in S3 or through Front 50. So a plugin maybe you could hook in there and always return an extra pipeline or something. But yeah, let's talk about the types of plugins that we have available to us. So we talked about extension point a little bit, and extension points. Let's see, where's this one taking us? Just the PF4J stage plugin, which is our quintessential plugin example that we have. Please check out Spinnaker plugin examples. There's a bunch of examples there, and we've been updating them for each release. Oh geez, cool. So, okay. All right. So let's see, extension points. Again, these are in the core code base. So in Orca, there is this stage definition builder that extends the Spinnaker extension point, right? So this is in Orca, and this is tied to a particular release. This is something that the core Spinnaker maintainers will be maintaining, is these extension points. And the idea here is that they're long-term stable, like I said earlier, interfaces that you can build your plugins against. This hopefully has less maintenance, as the interfaces should not be changing too rapidly, as they're public-facing interfaces, right? Contracts. So if I'm a plugin developer and I want to do something that does not have an extension point, I either need to wait or create the extension point myself and contribute it back upstream. Depending on what your timeline is, that might be okay. That might not be okay. You might need something in a short term where you can add some functionality to Spinnaker that you normally couldn't do because there's no extension point. In that case, you want to go a little bit off the rails. That is the Spinnaker extension point, and you will be creating a Spring-based plugin. So if we take a look at the Spring example plugin, so if we go to Spinnaker plugin examples, we have a Spring example plugin, and if we take a look at this plugin, we'll see there is no extension point that it's building off of. And in fact, it's not inheriting or extending plugin, it's extending the Spring Loader plugin. So this enables you to write your plugin code as if you were writing Spring. So a lot of Java developers have Spring experience, and this is a nice way of utilizing that. In addition, if there's not an extension point available, this is how you would implement your plugin. Because there's no extension point and you're relying on Spring, you are basically tied to implementation details. So creating a Spring Loader plugin does incur a higher maintenance cost, and you'll have to maintain your plugin a bit more release to release. You know, ideally, in patch releases won't change anything, and maybe minor releases you might have to update, but that's the intent there. I see a question on alpha and beta annotations describing the level of maturity. That's correct. Exactly that. The alpha and beta annotations do describe levels of maturity. Oops, that is one password. With a little caveat, I guess. There's so in each of the services, and thanks Suda for asking the question. In each of the Spinnaker services, there's now these API packages. So service-API. In these packages, we have the extension points. Now, Stage Definition Builder was basically lifted from, I forgot where it was, Orca Core or something like that before. There is a beta annotation on it, but it's the same exact code that we've been relying on for quite a long time. So the only difference is now it's extending Spinnaker extension point. So it is a beta annotation. I'll say it's maybe more of a, let's say, we're still figuring out the criteria for promoting an extension point to a, let's say, production ready or not alpha or beta annotatable. I'm not using the right words, but we're basically coming up with a list of like a process to move code from core into extension points, and that includes documentation, tests, etc. Right? So as we add more of that stuff, we will be promoting this from alpha to it's already beta now onto something else. Maybe just no alpha or beta annotations. Within Spinnaker, there's a pretty strong lack of testing, and this is something that we're hoping to improve on. Pulling extension points into API packages and having them be well tested would be awesome. All right, and we were talking about Spring-based plugins just right before that. So one thing to know that's different here about the Spring-based plugin is this package or this function here. Previously in the PF4J stage plugin, where we're based on an extension point, we just had start and stop. In this case, we need to tell Spring to scan the package that we want it to scan. Otherwise, it won't do that. This normally happens via annotations or just scanning the packages that are there, but we have to be a little bit more explicit and tell Spring to scan our packages. So here are the packages that we've got, and we can see in like properties, we can use cool annotations like configuration properties, just like you would with Spring. So this was not as friendly, let's say, in V1, and now this has become a little bit more friendly and easier to use. Okay, my internet is just extremely slow right now. But in the configuration, there is a configuration annotation. Here we go. Right, so the configuration annotation and enable configuration properties. So all these things that you're used to doing with Spring, you're able to do with a Spring Loader plugin. This is kind of an interesting method here. Maybe we'll talk about it a little bit later, but we have this exposed to app annotation, and this essentially is promoting this bean and promoting it to the main application context. And this is because it's overriding another service. I think that's all we're going to cover right now on Spring-based plugins. We will be taking a look at these a little bit later. In V1, we had the ability to do interface-based plugins. So what does that mean? Well, in PF4J, we have extension points like we talked about earlier. Something extends an extension point. Well, partway through developing the V1 framework, PF4J added the ability to create plugins based on any interface within the code base. So that's pretty cool. Unfortunately, as we moved to V2, that was broken. But we do have a fix coming for that in the next release. So in 1.24, that should be coming out, I think, in December. And then you'd be able to use interface-based plugins again. That's pretty nice because it's kind of a middle ground between a Spring plugin and an extension point. The interface has interfaces are generally a bit more stable than random code in the code base, so it's kind of nice that you can standardize on something a little bit more there. All right, let's talk about backend development. So we'll focus more right now on, we'll focus first on the extension point plugin, and then we'll look at a Spring Loader plugin. So I have a link that I will be, I'll share the slides to Slack, but for now, we have this random weight plugin. It's the PF4J stage plugin. You can see I pushed Spinnaker Summit branch here, and that's what we're going to take a look at. Spinnaker Summit 2020. I'll probably make this into its own plugin at some point, and then upload it to the Spinnaker plugin examples. I did not get to quite finish this example, as you guys can see, but I think it's a pretty cool and useful example for testing out both extension points, Spring-based plugins, as well as making requests from one service to another. Cool. So, and then returning it all back to the pipeline execution. So let's talk about the stage definition builder. So stage definition builder, what does it do? You're defining the stage. So in this example, we are making a random wait stage. All this does is it takes a number, and it will wait from 0 to that number, a random number of seconds, and then return that back to the application context. So I just took this PF4J stage example and have extended it a little bit so that it does a little bit more than just wait a few seconds. So stage definition builder is what creates the stage, and stages are made up of a series of tasks. So we have this task graph method that you must implement. Let's see, you do need to include both of these because you're implementing a method that already exists that's in stage definition builder. And for this in particular, we only have one task, and that is random wait task. So let's go and take a look at what that looks like. We're telling stage definition builder we have this one task and this one task only. If you have multiple tasks, you can add them and they'll be what's the word? Executed sequentially. Yeah. Right. Yeah. And let's take a look at the task itself. The task is what does the actual work. All right, here we are. So in the task, it's got an extension annotation. I did have to add this alias here, and we'll go into that in a little bit. But the random wait task, it takes in a config, and the config contains the default max wait time. So again, users can, in the UI, can put a number in, and this task will wait from a configurable number of seconds. But if nothing's defined, it'll use the default value. We're also using the plugins SDK. So anything that implements a Spinnaker extension point, which task is a Spinnaker extension point, you can also auto-wire the plugins SDK in. So this method has one main method, which is execute. Execute essentially is what does the work. Notice that we have to call this map to in order to get the context here. This is getting the configuration information that was passed to this task. So if you're in the UI and you have the max wait time set, it will use that as the max wait time. Otherwise, it will use the default max wait time, as mentioned before. Great, and then come up with a time to wait. Down here, we actually do the waiting. But this is kind of a fun little extension I added this time. We are going to be getting the Echo client and then making a call to Echo and then returning some of that information here. Cool. So that's quite a bit more detail than I think I was planning on covering at first. But let's get into a random weight plugin. As I said before, it's really just adding logging. Here you can do initialization and stuff. It's not I guess that exciting of a topic to cover. Let's see, next on here is the directory structure. So let's take a look at that. So the directory structure of plugins, we generally have a top level build.gradle, Gradle properties and all that fun jazz. You can see in this plugin, there's 3 different packages here. Because I named because it's been a random weight stage example, I just continued on with that. So you can see random weight deck that contains the deck components, random weight Orca, and random weight echo. So what this is showing is each of these packages affects one service in particular. So all the code that goes on Orca is in the Orca package, and it has its own Gradle file. This is a pullover from the Spinnaker services where we have all the Gradle files named as the package. I don't think it's completely necessary. Cool, we can take a look at this plugin right now. The source compatibility is, we're targeting 1.8. Services are moving to Java 11, so this will be just 11 in the future. But right now we have this here for some backwards compatibility. Most of this is pretty generic Gradle stuff. We are using Kotlin in these plugins, so you're going to see a little bit of Kotlin and cap stuff, I guess. I forgot what that was. But one thing to note here is this Spinnaker plugin stanza. We give it the name, the plugin class, so we point to the actual plugin class itself. And this requires field is interesting. So this requires field is saying, I, as the plugin, need to be running on Orca later than this certain version, right? So you see 000 here. That's because it's kind of actually hard getting the service version across different types of releases. I don't want to get too deep into version compatibility, but we are working on improving that right now using testing, and we'll get into that in a little bit. Why does this directory structure matter? Well, when we build the project, as we'll see in a little bit, we will have different files essentially for different services. So this code will, in the end, get loaded onto a service prior to starting up, and then get loaded in as it starts up. Cool. So if we look at the stage class, which we did look at the stage class a little bit already. So we kind of already went over the stage class here. We are in early stages of plugin development. There's been some challenges, and most of the challenges do come around with versioning. We do have a couple different versioning schemes in the Spinnaker community that we are working on finding compatibility between those. So once that's solved, we'll have quite a bit better of a foundation, let's say, to build on. Not that it's not solid, we need to be able to convert different types of versions to each other to say, hey, we've actually tested this plugin against this version of Spinnaker, and we know it'll work. we want to have solid guarantees around that. And right now we can do that, but it's a little hard with, there's open source versions, there's Netflix versions, and then Armory, we have our own versions as well. So there's all these different versions coming around. Ooh, how can we help during this hackathon? That's a great question. Let's chat later about that, because that would be fun. I think just exercising the plugin framework and using it would be a pretty great thing. We had some plugins developed at the last Spinnaker Gardening Days event, and either improving on those or creating your own plugins would be great. Because we had a question here, let's go and check out get Spinnaker issues. I would recommend, if you take a look at Spinnaker issues, if you maybe check out stage, there's probably going to be a bunch of stages that people either want created or yeah, like different stages people want created. So I would totally take a look at maybe creating a stage that someone's asking for in the issues. I think at one point I saw a fail stage request or something, and that might be kind of a cool, simple plugin to create, is just creating a stage that fails all the time. Yeah. Cool. All right, yeah, let's take a look at the task. So the random wait task, it's got, we talked about this execute method, and we went kind of in detail on this a little bit already, where we get the context that was passed to us from the UI. We figure out the time to wait, we do the wait, we use the SDK. So let's actually talk about this SDK real quick. I'm going to open up, here we are. So there is this plugin SDK that we can take a look at. So this plugins SDK, again, you can, it's got a good doc string up here, but any extension point, you can auto wire the plugin SDK in. So that's what I did here in the random wait task. Random wait task, it inherits from task, which if we take a look, task extends again Spinnaker extension point. So we are able to pull in the plugins SDK for free. It's pretty great. If we take a look at it, there's a few different things that, oh, yeah, I'm glad there's a couple people in here. There's a few things that this provides for us. There's this HTTP client live registry, YAML resource loader, and I'm not actually entirely sure what the third service is. It's something for serialization, deserialization. If we take a look at this HTTP client registry, there's both get, so you can get some client that was already configured. I think you can get retrofit and stuff now, or you can also get a client that will talk to an internal service. And that's what I wanted to show off today, is how to do that. So that's what we're doing here, is we get the plugin SDK, we get the HTTP client registries, and we call this method get internal service, and we just pass it echo. Don't have to worry about like spin-echo or anything. I can just pass echo, and it gives me an echo client. I create a pretty simple request, and by the way, this request is like a Spinnaker request, Spinnaker plugins request, right? So it's not like your HTTP request or anything. Then we will just call get on it and get the list of subscriptions. We'll be demoing this today. I don't have any subscriptions set up, so it's just going to be an empty list, but we'll be able to debug and see all this kind of stuff happening, which is pretty cool. So that's kind of like a quick TLDR on using the plugins SDK. there a list of all extension points and extension points to come? I believe the list is out of date. I think we had one online, but we should be improving that soon. There's a few right now. Stages, I believe notification types, and I think custom spell expressions. Extension points to come, that's also a really good question. Part of it's motivated by let's see, extension points will be built by us as well as the community, and that'll probably be based on like how much desire is there to extend a certain piece of functionality. For instance, I think pub sub might be a pretty good target in the future, like being able to add a different pub sub target via plugin. There's kind of two different tracks that plugins and the plugin framework enables us to go with Spinnaker. So if you want to build, yeah, just pick anything you want. I would say or encourage, there is a sorry, the question in chat, I'll repeat it for everyone online, was like, hey, is there a list of extension points? And if I wanted to build one, do I just pick anything? I would encourage, if you do want to contribute and build an extension point, we have a plugin working group sync every Friday at 10 a.m. Pacific time, that I believe is on the SIG calendar. So come in and join us. Happy to have you there. And yes, we do want extension points because then that makes it like easy for everyone to build off. Extension points, you do want to have some thought put into them because we do want them to be like long-term stable. Of course, they can be added as an alpha or beta tag, right? Which, let's see, which maybe gets back to the idea of, I lost my train of thought here. Extension points still to come. Yeah, I kind of forgot what I was going to say there. Let's see. If you do want to create a plugin, though, especially during Spinnaker gardening days, we do have Spinnaker plugins. So there's two repos that I can link in chat. We've got a Spinnaker plugins repo, and then there's an organization, Spinnaker-plugins. And this is a very new organization. This is, oh, check it out. There's two plugins here. I did not know that. Before it was just one. So Spinnaker plugins is an organization that when you have a plugin ready to use, that maybe you want to host it in your own org, or maybe you want to host it in your own username, or maybe you want to donate it to the community and have the community, well, it's not community owned and managed, it's community owned, but the maintainers are still the maintainers. The community does not, or SIG leads don't have ownership or maintenance responsibilities on plugins that are created. It's all, okay, so this one's not actually used, it looks like. This one, account registration, yeah, this one actually has a bunch of stuff in it and is useful. So code could be uploaded here to Spinnaker plugins. Now we'll talk a little bit about how plugins are discovered, and that is going to be this repo, Spinnaker/plugins. So we'll have basically two different repos that you can use. A community managed one, as you see, there's nothing in there right now, and same with official, there's also nothing in there right now. Eventually, these plugins will make their way into these repositories here. I hope that was not too much of a side tangent, but let's continue on. So here at the end, so again, we're back here in the task. We have the response from Echo for our pub subscription list. We have the time we actually waited in seconds, the time to wait. And what we're going to do with that is tell our pipeline execution about it. And here we are. Here we've got this outputs and context. There's not super strong conventions around this, but I think we're moving to have a little bit stronger of conventions around what context and outputs actually mean. I mentioned earlier that sometimes stages have multiple tasks in them. And the idea with context is a map of information to share between different tasks, and outputs is something that you would like to share with the pipeline execution as a whole. So in this case, well, we did not need echo, but if we had another task, it might be nice to tell the other task how long we said we were going to wait for as our max wait time. And then for our outputs telling the pipeline execution, we want to tell them like, oh yeah, we actually waited this long. And by the way, the subscription list for PubSub is this list. Cool. This has been changed recently. If anyone had checked out my previous talk, this is a very different plugin than it was before. So previously it was based on Simple Stage, which was an extension point that that did a lot of this stuff for you. It had some nice improvements to the stage definition builder. With stage definition builder, there's no concept of like strong typing here, right? For like inputs, outputs, and the context. So with the simple stage, it was a little bit nicer. You could kind of have strongly defined inputs and outputs. And the idea that one thing we would like to do is provide kind of another interface, a wrapper on top of stage definition builder that provides those quality of life improvements. Let's see. With stage definition builder, sorry, with simple stage, it was quite simple. There was nothing much you can do with it besides run some code and get the results. With stage definition builder, you have the power of all the stages essentially, or you have extra powers available to you. You can have your stage implement not just stage definition builder, but cancelable stage. And then now your stage can actually be cancelable as well. You don't have to write the logic for that. It just gets hooked in with the rest of the lifecycle. So that was task in the plugin SDK. I know we got quite a bit off topic there. I did want to call out the input, context, and output because that's what I was just mentioning. Those are not as strongly typed now with the stage definition builder, where previously it was maybe a bit more strongly typed. So let's take a look at some backend development for a Spring Loader plugin. We kind of took a look at this a little bit already, but if we look at which product is this? This is my PF4J stage, perfect. So what I'm going to do is close all of these and just open up the Echo side of things. So everything we've seen so far has been for Orca, stage definition builder, tasks, etc. What we're going to take a look at right now is what it looks like to make a Spring Loader plugin, a Spring-based plugin. You can see that right here. So I kind of went over it a little bit earlier. We have this method package to scan, and it will scan these packages or this package and pull all this code in. We've got a controller here. I do apologize. This example is not quite working, so I'll leave that as an exercise to the reader. That might be a fun Spinnaker Gardening Days task, let's say, is to make this a bit more of a better example. But I've recently been getting into like LED programming and some like hardware stuff. So that like microcontrollers and stuff like that. So that's what I decided to make a controller for. This has nothing to do with Echo. This is really just to show, yes, we're definitely going to be building and debugging a plugin at the end of this as part of the workshop. Yeah. This is right now we're doing an overview, and soon we'll be getting into the rest of it. And this, by the way, it does kind of work. It's just not giving me the answers I would expect it to. But we can take a look at that in a little bit. So this controller, again, I'm just giving it the annotation. It's a Rust controller. And here's the mapping for it. It's /LED. Great, I've got this random wait service. And what does it do? It has this get LED colors, and the LED color is based on the properties, right? So I kind of wanted to show that, hey, you can write a Spring plugin and just add a whole new like service to Echo that either maybe it uses some of Echo's resources, or maybe it's just something completely new that you wanted to add for whatever reason onto Echo. So we've got these properties. I just put it under blah, and then it has an LED color. Originally was colors, that's why it's get LED colors, but singular color now. This is also unneeded, but it could be kind of a fun way of viewing the properties. So if we had a get mapping for properties, we could see the random weight properties that we got here. This should be all pretty standard stuff. Here we've got a configuration. This actually did bite me a little bit at first. I didn't have the random weight config, the right properties, and this was just not, IntelliJ is giving me some crap about it, but it does work. So that is the Spring-based plugin. I think we covered all these different topics here. We've got the plugin, scans the packages. We've got the controller that has the request mappings here. We have the random weight service that does the actual job. And we've got the properties that defines the properties we want, as well as the config that puts it all together. Cool. All right, so debugging. Let's see, I think we're getting, right, yeah, let's just go into debugging a little bit. So this plugin is standalone right now. It's in its own IntelliJ project. Does everyone here use IntelliJ? I hope so, because that's what this is geared towards. Most of our plugin and Spinnaker development is geared towards IntelliJ, at least in my experience. So cool. Plugin here, we've got this task called release bundle. So I guess I should probably talk about the build Gradle. We've got this plugin bundler package here. And this is some quality of life stuff for helping out with plugin development. Awesome, glad to see people are using IntelliJ. Not affiliated with JetBrains or anything. I'm just that's just what we have our examples with. So if we take a look at Spinnaker plugins, we have this release bundle job. So let's run release bundle. I like Vim myself, highly recommend the idea of Vim plugin. Years ago, I gave a bug report for that, and it was fixed like right away. I was pretty impressed. I'm very happy because then I had some functionality back. Cool. So we ran release plugin just now, and what happened? By the way, I usually run this on command line, but you know, you're able to do it here in IntelliJ as well. What's going on right now is this build directory was empty. And then now it's created and has this plugin ref file. This is what we'll be using for local development and debugging. It also has distributions. So Orca zip. Okay, let's also look at this top level build. We've got this PF4J stage plugin snapshot and a plugin info JSON. This is a lot we're going to cover right now, I guess. So let's just get to it. Each package has its own. Remember, I was talking about the directory structure earlier. That's partially, I mean, this is one of the reasons for that. The output of this release bundle is essentially a zip of zips. So this zip up here, let's see, can I just like double click it? Probably not. Okay, I'm just gonna leave that be. But this zip is a zip of the zips from each of these individual build directories. So build, distribution, these zip files, there's 3 different zips comprised in this top level zip. When a service starts up, it will download the zip file and pull out the package that it needs in order to load the code and run it. And we will see that happening. We may see that happen today, maybe not, depending on how we run our stuff. So with, let's see. In each of these packages, we also have this plugin ref file. The plugin ref file is used for debugging, and this is something that we're going to be copying over to Orca. So this is in the Orca package, and we're going to copy this Orca ref, plugin ref, to Orca, and I'll show you guys how to do that in a sec, or where to put it. Let's see, in this top level distributions as well, there's this plugin info.json. So let's take a look at what that is. This essentially talks about the plugin and has an idea of like the releases. So if we take a look at the an example repository. Plugins are, I mentioned a little bit earlier that we use the PF4J update in order to distribute plugins. So what essentially happens is there's a repository that you can configure per service and or per Spinnaker, depending on how you do your configurations. But you point to repositories, and these repositories can be either a list of repositories like this. In fact, this one just points to this plugins.json file. So you can point to plugins.json directly, or you can point to repositories.json that eventually points to a plugins.json. Do note that it's a raw GitHub link. But what essentially we're checking out here, and what you do to get the raw link is you click raw. So that's the link you get. And we can see the Armory weight plugin, which is the plugin we're looking at over here, has a bunch of different releases. So it's got a description, a provider, which is generally the URL for the Git repo, and then different releases. Note that this has a URL, and locally it does not have a URL. Well, it's because it hasn't been uploaded anywhere. So we have GitHub actions that help out a lot with creating and managing the plugins info .json files. I definitely recommend taking a look at the PF4J stage plugin workflows here. So we have a few different workflows here. We have build, we have latest Quark and latest Orca, which essentially runs every 15 minutes and pulls down the latest versions of Quark and Orca separately, and then build against them. and then will alert us if they fail. The interesting thing here, though, is release. So whenever we do a release, we upload the release asset to the GitHub releases, and then we release the update the plugin repository with the release information, which essentially is that plugin info.json plus a few different pieces of information here. Okay, so that's like quite a lot to cover. Happy to help get people started with that, either in the workshop or afterwards. Just hit me up on any of those channels I mentioned earlier. Cool. So the plugin info JSON, we're not going to use that at all today. We are going to be using this Orca plugin ref, as well as, I mean, might as well try it out, the Echo plugin ref as well. Yeah, so the question in chat is, it'll be nice to have built a sample plugin, debugged it, and maybe made something happen in Spinnaker, hands-on. That's more my method of learning. We will get there. We're getting there today, or that's the intent. We still got about an hour, and if not, happy to help hop on Zoom or whatever later on, because I want more plugins around. So cool. Sweet. So let's go into how we do this actually. I've already done this, so I'm just going to show the steps that I have done. But let's go through it. So we ran this release bundle script within our plugin project. I'm just going to go over to the terminal real quick. I'm in the top left over here. Let me know if it's too small. I'm happy to increase the font size. I did improve or decrease my resolution to hopefully help with that. But here I'm going to do a Gradle release bundle. It's going to do exactly what happened earlier. Just make this full screen. And you can see I'm in Git repos, Spinnaker plugin examples, pf4j stage plugin. So I ran this earlier, but I'm going to copy my random weight Orca build Armory random weight plugin, the plugin ref file, and I'm copying it to my Git repos, Spinnaker Orca plugins. So in my Spinnaker project, my Orca project, I have this plugins directory defined here at the top level, and I've got that same ref file here. So I'm going to run this, copy it over. Nothing should have changed here. It's still pointing at the same jars and everything. Cool. So that's running release and copying the service ref to the plugins directory. Let's now talk about adding the plugin project to Orca. So here I am in Orca, the Orca project, and on the Gradle side, I'm going to hit the plus. Go to where my plugin's located and open up the build.gradle file. I already did that, which is why pf4j stage plugin is there. But when you do that, that's what will appear. So you'll have your stage plugin pulled into your IntelliJ. Let me send the link in chat to the plugin repo so everyone can follow along. And this, again, is Spinnaker Summit 2020. So I'll post this in chat. Please feel free to, I'm going to post this into Spinnaker or Summit-plugins-workshop in open source as well, which I will link here too. Cool. So if you clone this repo and then check out this branch and build it with the Gradle W release plugin, you will have this output here. You don't really need to open up IntelliJ for it. We're basically just going to get the ref file over, and in fact, I'm just going to close this guy because within the Orca project, I now have, because I added it to Gradle, on the Gradle tab, it appears here on the left side for me in IntelliJ. So I now open up all these files in IntelliJ in the same project scope and modify. And then do remember every time you modify, you should run release bundle because it'll build, and then that's how Orca will pick up those changes. Cool. So let's close some of these files. And let's see. So we added it to the other project. Now we want to run from main. So let's do this. I have set this up already, but we'll do it again. So a lot of the times I run via Gradle. So I've got a bunch of these like Orca web run. Great, it just runs it, right? But in order to build with the release bundle. Release bundle. Let me spell that correctly. Would just be awesome to misspell it and type it in chat, huh? We can do this. Copy and paste for the win. All right. So here, let's go to application, and we're going to want to create another application. Run configuration, and this will be Spinnaker Summit plugin development. Cool. So here, I'm going to choose in for my main class. In Orca, we're going to go to Orca Web down here at the bottom. One thing to note with Orca, I have the release 123X branch checked out. This is the most recent release, and it might be a few commits behind master, but if you want to build a plugin, you generally target a particular release for it. Well, plugin framework v2 came with release 123, hence my using the release 123 branch. So here, we're going to choose the main class in Orca Web, source, main, Groovy, not Groovy, I think it is in Groovy. Here, we want main. And we're going to hit OK. The VM options here, I'm just going to copy them from here in the PF4J stage plugin. We have these instructions here. So it helps a lot. Run the release Gradle or release bundle, copy the plugin ref file in the build to the project submodule. Great. Well, mine's top level, I guess. Link the project by using the plus in the Gradle tab. Configure it the same way as before, but we want to have a new run configuration with this VM option. Let's copy this VM option. And that's going to come here in VM options. Cool. The module here, the module is going to be Echo Web main. Goodness, I should just type web in. And then down here in the before launch, I remove build, but I add in build project. This is necessary to do debugging. So let's apply that and hit OK. All right, now if we want to run, cool. Now if we want to run this, we can put a breakpoint in the start method and start it up. Let's see it go. Okay, sorry, I'm just checking to see if telepresence or whatever was running. So Orca should start up. And now what we're looking to do here is really get a breakpoint here in start. So this is running Orca running locally, not talking to any Spinnaker installation or anything. It's just Orca running. And now we can see we're here in the random wait plugin. Random wait plugin method in start. Cool. That's what I wanted to show you guys with this section. So let's go on to front-end development. Just as a quick peek here, we've got front-end development, build, deploy, and the workshop itself. We're kind of like, I don't want to spend too much time on this stuff, so we'll try to go a little bit faster here, because I would like to make sure you guys can actually try to release a plugin today, or do the end-to-end. So front-end development, let's just take a look at the plugin itself. So in deck, let's see which we want to talk about. I'm going to close both of these guys. Rollup config, package JSON, and the random wait stage. So random wait stage, rollup config, and the package. Yeah, so package JSON is your dependencies and stuff, right, for NPM and all that jazz. So that's if you're doing front-end coding, this stuff should be pretty standard. Your rollup config essentially takes your helps build all your stuff together. I am not a front-end developer myself, so I'm probably not the best one to be explaining or discussing this, but we got it working. So the random wait stage is kind of actually the most interesting part of the front-end part of the project. So we have defined a random wait stage here, and essentially what we're doing, it's part of this stage type config. This all gets like hooked up, wired up, and registered with a stage registry. This contains the key. This key needs to match, actually it does need to match in Orca. In the random wait plugin, there is a, random wait, stage definition builder has a get name. Maybe it does not anymore. It used to have a get name method that would associate the name of the stage with the stage itself. I think this is done automatically now based on the class name. Strips out stage in lowercase is the first letter, if I recall. I haven't touched that in a bit, though. It has a description, and then a component, which is the stage config. So when you are configuring the stage in the UI, which we will take a look at, this is how you do it. You're essentially, this is right, pretty React. Like you just return a div with all the necessary components in it. We're mostly concerned with this, the max wait time. It's got a cute little label and some help fields. This is the input for when we make a request to the backend, this is how it gets sent over. Execution details section. So this is when you're running a pipeline in the UI. There's these execution details, both for the stage as well as for a task itself. And then there's a validate function to ensure your what you're sending over is valid, right? So if you're sending the max time to wait, well, it should be a number and it should not be negative. All right, so that's the front end development part of that. One area that we do want to improve on, right now there's really strongly connected components, let's say, between Deck and a lot of the backend services. So what you just saw here is, right, if we wanted to have a front end for Deck in the configuration, we have to do this. Why? Why can't there be an endpoint on Orca that has this kind of information and then we just render it on Deck? So if you are looking for fun side projects, or maybe not side projects, this would be a huge benefit to like the community in general. We started to do this with notification types, if I recall, where rather than having a hard-coded list in Deck, so when you want to change the add a new notification type, you have to go to Echo and Deck. Now you can just do it in Echo and Deck will pick it up. We have an example in one of our plugins. Pretty sure it's an open source one. So like this is a lot of work. I think most of us who work on Spinnaker are backend developers. So making it easier for backend developers to make updates and modify the UI would be kind of nice. Deck is probably the one piece that we haven't paid as close attention to in the plugin framework. However, that's going to be changing in this next year. We're getting a lot more interest in it, in extending Deck itself, and that's a really good motivator for improving it. Cool, so let's talk about build. The project structure, we kind of went over the project structure a little bit. Is there anything in particular I wanted to show here? No, just the PF4J stage plugin. Okay, it's good here. Oops. We can talk about Gradle.properties. So if we look at Gradle.properties, you can see Spinnaker Gradle version that has the plugin like wrapper type stuff. I'm gonna close this window over here because it's getting bright. All right. There's the PF4J version, which honestly doesn't change often. There's a Quark, Orca, and Echo version, as well as a Kotlin version. So Kotlin is very similar to the PF4J version. We don't change it too often. With Quark, Orca, and Echo, those are updated with the build, the GitHub actions I mentioned earlier. So we are looking to improve how that's done. Right now, it's kind of simple, where if there's any new release, we will go and build and test against it. What we want to do in the future is kind of respect the state of the world a little bit more, where there are these big bang releases, like 123 just came out. So we are wanting to move into having a release branch format for plugins as well, where, hey, if there's a 123 release, you should have a release 123x branch, and that branch's dependencies are kept up to date. It doesn't quite make sense to just keep getting the latest for everything, because you can have a little bit of mismatch there. So we talk about settings.gradle a little bit. This is something that has bit me a few times. This includes here. Don't forget to include the different packages that you're creating. We do, like I mentioned earlier, we do have this kind of convention in the Spinnaker side of things, where we have the build files that are named the project name.gradle versus just like build.gradle. We also have some plugin management stuff here. You can get the Gradle plugin this way. Next is let's take a look at Build Gradle. Build Gradle. Oh, we did kind of take a look at it earlier. This is kind of the most interesting part of it is this Spinnaker plugin or Spinnaker bundle, which helps with creation. This informs the task of releasing the bundle. Here you can see we're actually saying, hey, like if it's not deck, if it's not deck, make sure we have spotless rules on it for like code clarity and all that jazz. Okay, Orca Gradle. Let's take a look at that. This is, I mean, very similar, right, to kind of what we just looked at. The Spinnaker plugin is that same thing there. What is this? YAML. Okay, I'm just gonna ignore that for now. All right, GitHub Actions. Let's take a look at that. Workflows. We did kind of take a look at these earlier, so I don't want to spend too much time on it, but we recently updated them to use Java 11 via the GitHub action itself versus in the code, again, for backwards compatibility reasons. Our target in the plugin is 1.8, even though we're building with 11, it has backwards compatible. It's backwards compatible. Yeah, we kind of went over this, uploading the release asset and adding the release to the plugin repo. And then we went over a release bundle as well earlier. All right, so let's talk about deploy. This is really where the plugins JSON file comes into play, and as well as that repository's JSON file. We went over both of those a little bit already right here. So this is essentially, if you're going to be using this in a running Spinnaker installation, you will have your that zip of zips, the pf4j stage plugin dash version zip uploaded somewhere that is accessible by Spinnaker. So when your service starts up, it will download this repositories file. It will figure out what version you have configured, and then we'll download the zip, unzip it, and then start it up. Let's talk about the operator, backend services. Backend services is just the pf4j update. That's all it links to. It does have a bit more information here on the plugin repositories format and versioning. Again, we have extended it a little bit, so there's a bit more that we've added. We have been adding a compatibility. We go and check out here. We've been adding this. I don't see it here yet. Okay, so we haven't actually released anything with it. But what we are going to be adding is the compatibility section here. Actually, it does exist if we look at our pf4j stage plugin and look at the plugin info JSON. There's an empty compatibility matrix here. It's because I removed some of the build.gradle code that would do this. That's a really good question. So in chat, we were asked the question of how does it handle updates? Would it be through manual intervention only, or is there a notification of update available? So that's what we're working on like right now. There's a few different, there's quite a bit that goes into it actually, as you as you get deep in the weeds here. So right now, updates are not handled. So it would be like a manual update. We are investing in the compatibility between plugin versions and then service versions and then Spinnaker release versions, and all of these things play into each other, and that's kind of what I was referring to with the branches for plugins. So we're currently working on this, and we are working on a Cleat module that would allow you to query a service we're running that has compatibility information. So this is still kind of, as Cleat becomes the new hotness, the new tool to use, that's what we're going to be, I think, standardizing on. I'm not entirely sure the end result there, but we're working on a service at Armory right now where we will read in the different types of compatibility information that is generated here via the Spinnaker Gradle plugin. So the plan is to read this in, we have a service right now that will determine, given a plugin version and a service version or Spinnaker release version or what have you, are these compatible? So we want to be able to ask different types of questions, and that's a work in progress. Then the next step is to have Cleat reach out to that service and use that information for determining if you need to have a new plugin or not. It's still pretty early on in that sense, but now there's been a lot of discussion around versioning and stuff within the Spinnaker community. It's been taking quite a while, so we decided, hey, we're going to build a service that will solve it for us and the community, so we can have solid understanding of compatibility, because it's really important. And when you upgrade to a new version, you want to be able to upgrade confidently. That's also going to go play a little bit into the we talked about Spinnaker/plugins. There are going to be differences between official plugins and then community plugins. The official plugins will most likely have a little bit more testing. So if you think of like a Docker blessed image like Nginx, there's not like Nginx/Nginx, it's just Nginx, right? So that's kind of the idea here, is it'll be like tested and all that jazz. Which is one of the reasons why there's nothing here right now, is because there is none of that exists, or it exists but more like internally, and we're working on making that more public facing, I guess, thing. We will talk about the operator in a sec, but let's go on to Deck. So we're talking about all about deploying. So Deck is a React and Angular service. So it's not the same tech stack as everything else in the Spinnaker ecosystem. So how do we tell Deck to add some more code in? Well, we have a way of doing that, and essentially Deck needs to pull in some more JavaScript, right? Big surprise. In the past, I had uploaded it to like a index.js to S3, but then I had to deal with cores. And that was kind of a pain in the ass. Probably shouldn't have said that, but it was a pain. Now what we do is we actually have Gate proxies the Deck resources. So what that means is, if we take a look at the configuration, and this is something we'll be touching on in a sec, is we have in Gate, even though our plugin doesn't touch Gate, we have a section for Gate to say, hey, you need to proxy some resources for Deck. And in fact, this is the information you need. You need to go, this is the repository that tells you where the zip file is. And this is the plugins you need to look up in that repository. You need to look up the Armory random weight plugin, look up version 1.1.14, download that zip and then put it in the right place for Deck to consume. This gets around cores. This also makes it so that Deck is just talking to Gate. It's nice, simple, easy, and it works. All right, so let's get to the workshop. So there is a Summit plugins workshop in Spinnaker Slack, and so I would recommend joining that channel. We want to make sure that everyone has access to Spinnaker. Did anyone? I guess there's 2 of you guys at least in chat. Do you guys have Spinnaker set up via the operator? Did anyone join the new contributor workshop in, I believe, yesterday's session or Tuesday's session? I'm going to link this in both of these chats here. But here's this new Spinnaker contribution walkthrough thing. We're not going to go through this right now. It maybe should have gone through this a little bit earlier, but this is kind of a prerequisite for some of for this workshop essentially. Cool. So let's see. Don't have telepresence. That's okay. Telepresence, yeah, won't be able to follow along as closely, but okay. And then Spinnaker set up Docker desktop. Okay, cool, sweet. So what we're doing here, we're doing a couple different things. Is we have this Spinnaker contributor workshop, and then we have this Spinnaker service to use. Let's see, what's a good way of doing this? Does anybody need a Spinnaker installation in AWS? Because I am more than happy to create one for you, give you a kubeconfig file that you have control over, a namespace. Let me know if you guys do need that. But essentially what we've done is Fernando has, on the Armory team, he's created some quality of life stuff to quickly get up and running with Spinnaker using the operator. And we use this we have this Spinnaker customized patches repository that I highly recommend checking out. It has a pretty good description of how to get started with the operator and Spinnaker and using customize in order to maintain your Spinnaker installation. So I'm going to go over that just really quickly. Here actually real quick, this Spinnaker customized patches, let me link this in both of these chats as well. This is kind of a new type of a thing. It's a template repository, which I haven't actually seen before. Maybe it's not that new, but you can say use this template, and then it will fork it, or rather clone it, into your own repository. Pretty cool. So I've already done this. GitHub, and Spin service. So if we check out my Spinnaker service, it has all this stuff here. I'm not going to use GitHub to explore it. Let's just use the command line. So the customization YAML here is the main part of the code, I guess. So we have this Spinnaker, well, let's go back to this. What it's saying is you have these different resources. We have a Spinnaker service YAML, and we have some infrastructure, which is essentially defining Minio, so that we have our own local S3, self-hosted. And then we have a list of patches here. So in these patches, there's like a Minio key that I had to put in there, which is just some like crap data. And then I don't remember. Oh, the Kubernetes patches is for for some service accounts. And then this plugins is the latest patch that we're going to add. So if we take a look first at what the Spinnaker service is, our base, it's empty, except for our version 123.0. So when I do a kube control apply, I can specify the kube config file that I have set up. This is one of the ones set up from Fernando as well. So I have a kube config file. I just specify that every time. I specify my namespace as well, but I don't think you have to because the kube config file actually contains the default namespace. I'm running, oh, this is kube control, by the way. Oh, cool, you guys went through that yesterday, sweet. Just to finish it off though, apply -K instead of -F because it's customized. You just give it this directory. So since you guys went through this yesterday, let's take a look at what we're doing here. We have a patch plugin, and I call it patch plugin wait. And here, what I'm doing is we have in the Spinnaker config, this will go in and, oops, update Spinnaker config. So it will say, hey, I'm going to look at Spinnaker config profiles, and anywhere I see a like Orca or Gate or Echo, we're going to add these values here. So Spinnaker config profiles, it's kind of like a stack, right? So Gate in the earlier definition was an empty map, and now we actually are giving it configuration to add. Again, Gate, I created a release of this earlier, so actually quite a while ago. So 1.1.14 is the version to use with DEC. And again, remember, Gate is proxying that to DEC. So we have this plugins JSON repository defined here. Because I'm going to be showing you guys how to use telepresence and debugging, the configuration is a little bit different for Orca and Echo. We might take a look at Echo today. I don't actually think we'll have time, but we'll kind of go over what we're trying to do here. So Orca has the plugin configuration here. With version 2 of the plugin framework, there is no longer an extension list here, which is a huge quality of life thing. It used to be, oops, line 30. It used to be like my extension name, and then config, something like this, and then default max wait time. It used to be something like this. Big quality of life improvement. We don't need to know about extensions anymore. We can just get rid of that and have all the configurations under the config key. Because we're not going to be downloading this plugin from a repository, we're going to leave the repositories list off. Same with the version. We're going to be running it based on that plugin ref file. That's going to be used to tie in our plugin binaries with Orca. So I've already applied these patches to my Spinnaker installation. So down here. So if I do an apply again, nothing should change. Oh my gosh, something changed. Something was configured. Echo was configured. Great. I mean that should probably be fine. I think I just removed the repositories from Echo, if I recall, which is totally fine. Great, let's go. So we made the template from the patches. And, oh no, what's going on? So we wanted to add the plugins from to our Spinnaker installation via that patch file. And now we're like really kind of ready to go. So Spinnaker's up and running here. In this pane here, it's kind of a small pane, but what I'm going to be doing is doing these port forward commands. And let me just copy these commands and post them in chat. That did not copy well in the chat online, but it copied well in the Spinnaker or Summit plugins workshop in Slack. But what I'm going to be doing is port forwarding 9,000 from my local host to my cluster. And I'm doing that so I can reach Deck, the UI. I'm also going to be doing this with Gate, which is the gateway to, it's like the API gateway, right? So if I want to authenticate, for instance, I need to go to Gate. So I'm going to localhost to get to Deck, and then I also need to forward all the auth requests and all the other types of requests back to my Spinnaker cluster. So if we take a look at this right now, I can go to localhost 9000. Here, there was some cute little saying there. We can take a look at my pipeline, and great. I see some executions. I can see my random wait configuration is running. And by the way, this is all running against not my Orca locally. This is like Orca in Kubernetes. So I can add a stage here. We can say random wait. We can see this cool pop-up, max wait time. Can't be negative, and then like 3. Okay. I'm not going to save this change. We're just going to go back. It's okay. We can see here we have some execution history. Whatever. We'll take a look at that in a sec. I would be surprised if this works because there's no stage or anything here in Echo. I do have a plugin configured, but it's going to fail because it didn't have any, didn't actually have any code because I removed the repositories there. It's a good call. Thanks for that. Let me edit the message in, what's it called, Slack real quick. Garden.yaml. Cool. Sweet. So this failed. Awesome. That's kind of actually expected. Again, it failed because Orca doesn't have, if we look at our plugins patch, there's no repository here. So when Orca started up, it said, hey, I don't have any repositories defined. Great, you have this random wait plugin enabled, but there's nothing to enable, so forget about it. So what we're going to do is run this telepresence command. I'm specifying my kubeconfig here, and I'm calling telepresence swap deployment, and let me just copy this into Slack as well, and I'll update this as this too. But I'm saying swap deployment spin Orca, and I'm giving it a telepresence file. This does not have to exist. So let's run that. Let's post this here. Oh, it needs my password. What's it called? I don't entirely know what happened, but iTerm2 had this thing recently with where I see that like key symbol, and for some reason I can't actually type a password in. I have to click on it. I'm not a fan of that. Yeah, not a fan. So let me post this command I just ran here in Slack. And we'll just say this is gardening. Cool. So right now, what's happened is if we see my Kubernetes cluster, the spin Orca container is now changed, right? The hash at the end is completely different than it was before. My connections are still being forwarded for 8084 and 9000. And now if what I'm going to do here is run my, this is Orca. So let's run it. Always exciting, waiting for services to start. Oh, that's good. Cool. So we started main here. Let's maybe like this. Okay, cool. So we can see we're actually already getting requests here from something, and I'm pretty sure it's from this guy. So let's take a look at our applications. Let's go Spinnaker. Take a look at our pipelines. And this is kind of a newish UI, so it's pretty cool. All right, let's hit start manual execution. And this time, now we see, okay, I have been getting this error where it's like, oh, I don't know what pipeline, no pipeline found, but then it finds the pipeline and actually runs it. Because we see now here, it succeeded. Awesome. Random wait, it waited 0 seconds. Great. Let's look at the source here. The source has the information of your pipeline execution. So here we have on the outputs, or in a context, remember we have our max wait time. I had the echo client just for whatever reason, just added it there, and you can see, hey, this is where the base URL is for, I'm not sure why it's for plugins there, but for echo, oh shoot, that's base URL. And then the name is internal echo. As our outputs, our time that we actually waited was 0. So we don't have the logic of like, oh, you have to wait at least 1 second. It could be 0 seconds. And as we discussed earlier, we have this subscription list here too. I didn't read it incorrectly apparently because it's a string here instead of just a list. Do with that what you will. Great. That's cool and all, but we're not actually debugged in here. So let's stop this and let's run it with debug mode. Cool. So I'm going to open up in my PF4J stage plugin the random wait Orca, and let's go to main. Let's go to our task because this is what we're going to actually be. This is what does the work, right? So let's put a breakpoint in here after we get the subscription list back from Echo. No worries. Please, yeah, please hit me up in the future, Justin. We're almost done with the workshop, so it's and almost at time too. So it's good timing. Cool. So you see, we stopped in the start method, like that happened earlier, right? Because it's loading up, and it started. So it did start. Great. So it started. Let's now run this pipeline again. You can see some motion happening down here, and check it out. We are in our we're in the random wait task, and we're debugged into here. So this is actually a response we got. So Echo, here's our Echo client. Here's our request, and here's our response, right? So our response body, it has, it's just an empty list, right? Size is 0. Subscription list, oh, see, okay, oh, it's 0, size 0, and it's an empty list there. That's kind of funny. Cool. So that's kind of that. Like we have a way right now to hit hit echo from from our plugin. If we just continue on here, we can see it now. You know, had it paused for a bit. We can now see it took 55 seconds, but it waited 0 seconds again. Is there a bug? Is it always just waiting 0 seconds? But now we can see here again the outputs here. So that's pretty cool. What I was hoping to show today that I did not get to was the same happening with Echo. So ideally, this could have been LED/colors. And then Echo would have had this wait service that would have returned the LED colors. And then we could have had, you know, this end-to-end from, I mean, we kind of do have this end-to-end from the UI going in, hitting Orca going to Echo, getting some, oh, thanks very much. Glad you're able to make it. Definitely let me know if you need any more help or anything on Slack. I'm very happy to help. If I don't see it, just tag me in it. Yeah. So yeah, so we went from Deck to Orca to Echo and all the way back. And we got this information here in our pipeline execution. And that's basically the workshop. So if you're interested in helping or learning out more, join us in Slack in the plugins channel. I'm also obviously going to the I didn't make it today, but I attend the platform SIG regularly, and we have some discussion there as well on more like maybe more broad initiatives. Yeah, tag me if you guys want any help, and always happy to help take a look at how people want to extend and enhance Spinnaker. Sweet. Well, thank you guys very much. That is the end of it today. Catch you guys later.